Two aircraft set side by side on Rabaul airfield in August 1943. On the left, the Mitsubishi A-6M0 Japan's pride, the fighter that had dominated the Pacific for 2 years. On the right, a captured Vought F4U Corsair bent propeller blades, bullet holes in the wings, but flyable. The Japanese test pilot assigned to fly both would write in his report, "We are fighting the next war with the previous war's technology." This is the story of how Japan's best pilots and engineers confronted American technological superiority by examining the very aircraft that was destroying them. It's told through test reports, engineering analysis, and the diary of the pilot who flew both fighters and understood what the comparison meant for Japan's future. The Corsair arrived at the Rabaul, Japan's major airbase in the South Pacific in July 1943. An American pilot had been shot down during a raid. His F4U-1 had crash-landed in a jungle clearing on New Britain. The pilot escaped, but the aircraft remained relatively intact. Japanese forces recovered it, patched the worst damage, and transported it to Rabaul for evaluation. This was not the first Allied aircraft Japan had captured. They had examined Wildcats, P-38s, P-40 Warhawks, even a B-17 bomber, but the Corsair was different. Even before anyone flew it, Japanese engineers recognized they were looking at something that represented a fundamental shift in fighter design philosophy. Lieutenant Minoru Suzuki was assigned as the primary test pilot. Suzuki was an experienced naval aviator with over 2,000 flight hours and 12 confirmed victories. He had flown Zeros since 1941. He knew the aircraft intimately, its strengths, its limitations, every quirk of its handling. He was the ideal person to compare the Zero against its American opponent. His first observation, recorded in his diary: "The Corsair sits high, much higher than the Zero. The entire aircraft is larger, heavier, more substantial. The Americans are not building fighters. They are building flying fortresses with single seats." Japanese engineers spent 2 weeks examining the Corsair before anyone attempted to fly it. They measured everything. They photographed every component. They documented construction techniques. And with each measurement, each photograph, each analysis, they became more concerned about what the comparison revealed. The engineering report, preserved in Japanese naval archives after the war, was remarkably detailed. Key findings included power plant, Pratt & Whitney R2800 double wasp radial engine, 18 cylinders, 2-stage supercharger, rated power 2000 horsepower, Japanese equivalent Nakajima Sakae, 14 cylinders, single-stage supercharger, rated power 1130 horsepower, American advantage, approximately 75% more power. Construction: all metal, stressed skin construction, aluminum alloys throughout. Riveting is flush type for reduced drag, panel gaps minimal, quality control appears excellent. Assessment: construction quality exceeds Japanese standards. Manufacturing precision would be difficult to replicate with our current industrial capabilities. Armament: 6 Browning M2 50 caliber machine guns, 3 per wing. Ammunition capacity: 2,400 rounds, total 400 rounds per gun. Rate of fire: approximately 800 rounds per minute per gun. Combined firepower: 4,800 rounds per minute. Japanese Zero armament: 2 20mm type 99 cannons, 2 7.7mm type 97 machine guns. Assessment: American volume of fire significantly exceeds Zero despite smaller individual projectile size. The engine particularly impressed and disturbed Japanese engineers. The R2800 was a masterpiece of engineering, powerful, reliable, well manufactured. But what struck Japanese analysts most was not the engine itself, but what the engine represented: American industrial capability. One engineer's report noted, "This engine requires precision manufacturing beyond our current standards. The tolerances are tighter. The metallurgy is superior. The quality control is consistent across all components. Most critically, Americans are producing these engines in large quantities. Intelligence indicates thousands of these engines have been manufactured. We cannot match this production rate or quality level with our current industrial capacity." Another engineer wrote more bluntly, "We are examining an American fighter engine and realizing we are not competing with American aircraft. We are competing with American industry. This is a contest we cannot win." After 2 weeks of ground examination, Suzuki was cleared to fly the Corsair. The first flight was scheduled for August 22, 1943. Suzuki approached the aircraft with professional curiosity mixed with personal anxiety. This was, after all, an enemy aircraft that had been shooting down his countrymen for months. Climbing into the Corsair's cockpit was immediately different from entering a Zero. The Zero's cockpit was compact, Spartan, efficient. The Corsair's cockpit was spacious by comparison, filled with instruments and controls. Suzuki's diary entry described his impressions. "The cockpit is like a command center, not a fighter pilot's office. Instruments everywhere. The throttle quadrant alone has more controls than the Zero's entire cockpit. Mixture control, propeller pitch control, supercharger control, oil cooler control, all separate, all adjustable. The Zero has a throttle and mixture control, that is all. American pilots have far more to manage, but they also have far more capability to optimize performance. Starting the R2800 was an experience. The engine did not purr like a Zero sake. It rumbled. It shook the entire airframe. When Suzuki advanced the throttle for taxi, the Corsair moved with authority that the Zero simply did not possess." Suzuki wrote, "The engine sounds like a factory, not like an aircraft engine, like an industrial machine. Powerful, brutal, unstoppable. I had flown Zeros for 3 years. This was something entirely different." Takeoff was scheduled for mid-morning when conditions were calm. Suzuki aligned the Corsair on Rabaul's main runway, advanced the throttle fully, and was immediately surprised by the acceleration. The Corsair gathered speed far more rapidly than a Zero. At approximately 90 miles per hour, he pulled back gently. The Corsair lifted off smoothly. His post-flight report was detailed and sobering. Initial climb rate significantly exceeds Zero. The power-to-weight ratio, though lower than Zero due to heavier airframe, translates to superior performance in most flight regimes. Climb to 5,000 meters took approximately 4 minutes. The Zero requires approximately 6 minutes. At altitude, the Corsair accelerates impressively. Maximum speed at optimal altitude appears to exceed 460 miles per hour. The Zero achieves approximately 350 miles per hour. This 110 mile per hour difference is decisive in combat. The Corsair pilot can engage or disengage at will. The Zero pilot cannot force combat if the Corsair pilot chooses to avoid it. But speed was only part of the assessment. Suzuki tested the Corsair's handling characteristics extensively. The aircraft was heavier than the Zero, approximately 9,000 pounds empty versus approximately 3,700 pounds for the Zero. This weight difference had significant implications. Handling. The Corsair is stable and predictable. Control forces are heavier than Zero, particularly elevator and aileron. Roll rate is good but not exceptional. The Zero rolls more quickly at low speeds. However, at high speeds, the Corsair's control response remains consistent. The Zero's controls become heavy and sluggish above 300 miles per hour. Advantage: Corsair for high-speed combat, Zero for low-speed maneuvering. Turning performance: traditionally, the Zero's greatest strength showed interesting results. Suzuki flew both aircraft and compared their turning capabilities directly. His report: at speeds below 250 miles per hour, the Zero outturns the Corsair decisively. The Zero can sustain tighter turns with less altitude loss. This has been our primary advantage against all American fighters. However, Corsair pilots are increasingly avoiding turning combat. They use superior speed and altitude to attack, then disengage before we can respond. Against such tactics, the Zero's turning advantage becomes irrelevant. We are optimized for combat that American pilots refuse to engage in. The diving performance comparison was particularly revealing. Suzuki tested both aircraft in full-power dives from 10,000 meters. Dive performance: the Corsair dramatically outperforms the Zero. Maximum dive speed appears to exceed 500 miles per hour. The Zero becomes difficult to control above 350 miles per hour and dangerous above 400 miles per hour. In combat, this means Corsair pilots can dive to attack and dive to escape. Zero pilots can do neither safely. This is a fundamental tactical limitation we cannot overcome with current aircraft. The armament test was conducted against a derelict Japanese transport ship anchored offshore. Suzuki made multiple gunnery passes with both aircraft to compare their firepower. His assessment: the Corsair's 650 caliber machine guns produce devastating volume of fire, approximately 80 rounds per second combined. Tracers converge at approximately 300 meters. Effect on target is immediate and catastrophic. The Zero's 220mm cannons and 2 machine guns fire more slowly, approximately 15 rounds per second combined. Individual 20mm shells have more destructive power than 50 caliber bullets, but the Corsair's volume compensates. Additionally, the Corsair carries 2,400 rounds compared to the Zero's 120 cannon rounds and 1,400 machine gun rounds. The Corsair can sustain fire for longer engagements. Durability testing came from examination rather than deliberate testing. The captured Corsair had multiple bullet strikes. Japanese engineers examined the damage and compared it to what similar hits would do to a Zero. The engineering report noted, the Corsair incorporates armor protection for the pilot and critical systems. Armor plate behind pilot seat, armored glass windscreen, protected fuel tanks with self-sealing capability. Total armor weight, approximately 150 pounds. The Zero has no armor protection. Design philosophy: Zero relies on not being hit. Corsair assumes it will be hit and protects accordingly. Combat results support the Corsair's approach. Zero pilots die from hits that Corsair pilots survive. One engineer wrote more philosophically, "We designed the Zero for the war we expected: short combat duration, decisive results from superior maneuverability, minimal protection needed because we would not be hit." The Americans designed the Corsair for the war they knew would come: extended combat, attrition warfare, industrial production replacing losses. Our aircraft reflects our philosophy. Their aircraft reflects reality. After completing flight testing, Suzuki submitted his final assessment to Naval Command. The report concluded, the F4U Corsair represents a fundamental shift in fighter design philosophy. It sacrifices some maneuverability for speed altitude, performance, firepower, and survivability. In the tactical environment that has developed, particularly American pilots increasing discipline in avoiding turning combat, the Corsair's advantages are decisive. Our Zero remains superior in turning combat, but increasingly we cannot force American pilots into such combat. Recommendation: urgent development of new fighter designs incorporating lessons from Corsair examination. Japanese engineers attempted to apply lessons from the Corsair to improve the Zero, but they faced insurmountable obstacles. The Zero was fundamentally designed around different priorities: lightweight, long range, extreme maneuverability. Adding armor meant adding weight. Adding weight meant reducing performance. The Zero's airframe could not accommodate a more powerful engine without complete redesign. An engineer's frustrated report from October 1943. We cannot simply copy Corsair features onto the Zero. The two aircraft represent incompatible design philosophies. The Corsair is built around a 2,000 horsepower engine. The Zero is built around a 1,000 horsepower engine. To incorporate Corsair level performance, we would need to design an entirely new aircraft. This would require new engine, we have none comparable to R2800, new production facilities, new manufacturing techniques, new supply chains, and time we do not have. Meanwhile, Americans are producing Corsairs at rates we cannot match even if we could design equivalent aircraft. Japan did develop new fighters, the Kawanishi N1 K Shiden, the Kawasaki Ki-61 Tony, eventually the Kawanishi N1 K2J Shiden Kai, which approached Corsair performance. But these aircraft came too late and in too few numbers. The Zero remained Japan's primary fighter because retooling factories would temporarily reduce production, and Japan needed every aircraft it could build. Suzuki continued flying both the captured Corsair and his operational Zero through late 1943. His diary entries show a pilot grappling with the reality that his beloved Zero, the aircraft he had flown successfully for years, was becoming obsolete. September 1943. I flew the Corsair again today, then flew my Zero on a combat patrol. The contrast is profound. The Corsair feels powerful, confident, capable. The Zero feels fragile. This is not a fair comparison. I am comparing a test aircraft to a combat-worn operational aircraft. But the fundamental differences remain. The Corsair is built for the industrial war we are fighting. The Zero is built for the war we thought we would fight. October 1943. American pilots are learning. They no longer try to turn with us. They attack from altitude, use their speed, escape before we can respond. Against such tactics, the Zero's maneuverability is useless. We are bringing swords to a gunfight. Actually worse, we are bringing swords to an artillery barrage. November 1943. New pilots arrive at our unit with minimal training. They fly the Zero barely adequately. They die quickly. I wonder, if we had Corsairs instead of Zeros, would they survive longer? Probably not. The Corsair requires more skill to fly well, but it offers more protection when things go wrong. The Zero offers no second chances. One mistake, one hit, and you are probably dead. How many pilots have we lost? Not because they lacked skill, but because the Zero lacks forgiveness. By early 1944, the captured Corsair had become more than a test aircraft. It was a symbol of what Japanese pilots face: technological superiority they could not match, industrial capacity they could not overcome, a future they could see but could not prevent. Suzuki wrote in January 1944, intelligence reports indicate Americans are producing over 1,000 Corsairs per month. We are producing approximately 200 Zeros per month. They build 5 Corsairs for every Zero we build, and their Corsairs are better aircraft. This is not a sustainable situation. We are fighting mathematics with courage. Courage is insufficient. The Battle of the Philippine Sea in June 1944, called the Great Marianas Turkey Shoot by American pilots, demonstrated the consequences of this technological and numerical imbalance. Japanese carrier aircraft attacked American task forces. American Corsair and Hellcat pilots achieved kill ratios exceeding 10 to 1. Japan lost approximately 300 aircraft in 2 days. American losses were minimal. Suzuki was not present at Philippine Sea, but he received detailed reports from survivors. His diary entry: the Philippine Sea battle confirms what the Corsair tests predicted. We cannot compete with American fighters when they are flown correctly. Our pilots are brave, our tactics are sound, but we are flying obsolete aircraft against superior opposition. Bravery cannot overcome a 100-mile-per-hour speed disadvantage. Tactics cannot compensate when the enemy can choose when and where to fight. We are doomed to lose this war in the air. Japanese engineers continued examining the captured Corsair through 1944, looking for any advantage they might gain. They studied the propeller design, the engine cooling system, the hydraulic systems, the radio equipment. Each examination revealed American capabilities that Japan struggled to match. A December 1944 engineering summary. Analysis of Corsair components reveals consistent pattern. American manufacturing precision exceeds our standards. American materials quality exceeds our availability. American design philosophy emphasizes reliability and maintainability, while ours emphasizes weight savings and simplicity. Most critically, Americans are producing these high-quality aircraft in vast quantities. We cannot match either quality or quantity. We are attempting to fight an industrial superpower with limited industrial capacity. This is not a winnable contest. By late 1944, the strategic situation had deteriorated so badly that Japan resorted to kamikaze tactics, suicide attacks, using aircraft as guided weapons. Some kamikaze missions used Zeros. The aircraft that had once been Japan's pride was now considered expendable, useful only when loaded with explosives and flown directly into enemy ships. Suzuki never flew kamikaze missions. As an experienced pilot with over 60 victories, he was kept back for training duties and occasional combat patrols. But many pilots he had trained were ordered to make one-way attacks. His diary, October 1944. I have flown the Corsair. I know it can be defeated by skilled Zero pilots using proper tactics. But we have fewer skilled pilots every month, and the Americans have more Corsairs. Now we resort to using Zeros as missiles. The aircraft that once ruled the Pacific sky is now a delivery system for bombs. This is what defeat looks like. The war ended in August 1945. The captured Corsair at Rabaul was destroyed during an Allied bombing raid in early 1945, ironically, possibly by Corsairs attacking the base. Suzuki survived the war and was interviewed extensively by American intelligence officers about his experiences testing captured American aircraft. In a 1946 interview preserved in American archives, Suzuki reflected on what the Corsair comparison had taught him. When I first flew the Corsair, I understood immediately that we were fighting an impossible war. The Corsair was not just a better aircraft than the Zero, though it was. The Corsair represented American industrial and technological superiority that we could not match. Every component, every system, every design choice showed a nation with unlimited resources and advanced engineering. We had courage and skill. They had courage, skill, and vastly superior tools. In the end, superior tools prevailed. Asked specifically about whether Japanese pilots could have achieved better results with Corsairs instead of Zeros, Suzuki's answer was thoughtful. Possibly yes, the Corsair was more forgiving than the Zero. It could absorb damage. It could outdive enemies. It could escape from unfavorable combat. Inexperienced pilots would have survived longer in Corsairs than in Zeros. But the larger question is, could we have built Corsairs even if we had the designs? I doubt it. We lacked the engines, the materials, the manufacturing precision, and the industrial capacity. The Corsair was not just an aircraft design. It was the product of an entire industrial system we could not replicate. In his memoir, published in 1958, Suzuki dedicated a chapter to his experiences testing the Corsair. The chapter's conclusion remains one of the most honest assessments by any former enemy pilot about the technology gap. The Corsair showed me that we were not fighting American pilots. We were fighting American industry. Their pilots were brave as ours. Their tactics evolved to match ours. But they flew superior aircraft produced in quantities we could never match. We designed the Zero for the war we wanted to fight, short, decisive, decided by pilot skill and aircraft agility. The Americans designed the Corsair for the war they knew would occur long, attritional, decided by industrial capacity and technological superiority. Their vision of war proved correct. Ours proved naive. When people ask me about the Pacific Air War, I tell them about flying the captured Corsair. In that cockpit, surrounded by American engineering and industrial might, I understood for the first time that we had already lost. Not because our pilots lacked courage or skill, we had both. We lost because courage and skill are insufficient when the enemy has superior tools and unlimited resources to replace losses. The Zero was a beautiful aircraft, perfectly designed for a specific role. The Corsair was a practical aircraft, designed for industrial warfare. Beauty lost to practicality, philosophy lost to reality. We lost to America. The captured Corsair that Suzuki flew was one of several American aircraft examined by Japanese forces during the war. Each examination led to the same conclusion. American aircraft reflected industrial and technological capabilities that Japan could not match. The Zero had been perfect for 1941. By 1943, it was obsolescent. By 1944, it was obsolete. But the Corsair analysis was particularly significant because it was so comprehensive. Japanese engineers examined every aspect of the aircraft. Pilots flew it extensively. The comparison to the Zero was direct and unavoidable. And the conclusion that Japan was fighting an unwinnable technological war was inescapable. Suzuki's final diary entry about the Corsair, written in April 1945 as the war neared its end. I flew the Corsair one last time before it was destroyed in a bombing raid. I flew it knowing the war was nearly over, knowing Japan had lost. I thought about all the pilots, American and Japanese, who had died in the air war. I thought about how many might have survived if both sides had flown aircraft like the Corsair instead of some flying Zeros and some flying Corsairs. The aircraft made a difference, not the decisive difference. Superior numbers and resources did that. But flying the Corsair instead of the Zero meant better chances of survival. That matters to individual pilots, even if it does not change war's outcome. The Corsair taught me that technology matters, industrial capacity matters, resources matter. Courage alone is insufficient. Skill alone is inadequate. When the enemy has better tools and more of them, bravery becomes tragedy. I survived this war. Many did not. Some died because they made mistakes. Others died because they flew aircraft that could not protect them, could not outrun enemies, could not fight on equal terms. The Zero was many things: beautiful, agile, long-ranged, but it was not forgiving. The Corsair was. That forgiveness saved lives. The lack of it cost lives. This is what I learned from flying both aircraft. This is what I hope others can learn without having to fight the war themselves. The story of Japan's captured Corsair is ultimately a story about confronting technological reality told through the experiences of those who flew and examined it. The aircraft represented everything Japan needed but could not build: power, protection, performance, and unlimited production capacity. Examining it was like glimpsing the future while being trapped in the past. Suzuki and the other pilots and engineers who worked with the captured Corsair understood something that their high command refused to acknowledge until it was far too late. The air war was not decided by pilot courage or aircraft agility. It was decided by industrial capacity and technological advancement. The Corsair embodied both. The Zero embodied neither. That is the enemy's perspective on the aircraft that changed the Pacific Air War. Not hatred or excuses, but honest recognition of technological superiority and industrial might that determined the war's outcome more than any individual battle or pilot's courage ever could.